Alrighty then, I think it's about time to get this show on the road, so that's a little bit better. So, with that little annoying text. So today we are taking a little bit of a shorter flight, I think. We'll be going from Toronto Pearson International Airport to Montreal Pierre Trudeau International Airport as WestJet E92. This is a Boeing 737-800 aircraft in lovely WestJet paint scheme. Not so lovely, with the jetway looking incredibly derpy, almost as derpy as it looked in Ottawa. So, I'll be showcasing all aspects of the flight, and hopefully people either learn something or find this really entertaining, although I sort of doubt that will be the case. Nonetheless, we'll have to actually find out. So, let's get into the cockpit, shall we? Okay, so I have not fully pre-flighted this aircraft, or at all. This is a completely dark aircraft. So, let's begin by establishing battery power. We'll go to the overhead panel, the battery switch, and close the guard, which will also start the switch. This will give us some incredibly basic battery power, which is essentially what you use in the air if you lose all of your generator power from engines or the auxiliary power unit. And this is enough to get the aircraft to the ground, but it's not nearly enough for our purposes. So we're going to connect to ground power. Should go into this menu and send a ground power unit. We're also going to set the fuel up. That's a different story. Okay, so there's the fuel. So this is basically what they would use at Pearson. They have a power unit which comes in through the jetway right over there, hooks up to the aircraft, and we can simply interface with the aircraft systems by clicking this switch. And the lovely fans coming in. I'm just going to ever so slightly turn this down. That's better. So let's get some light in here. Several different light switches. This one controls the overhead panel brightness. This one controls these lights, including the MCP panel, and these control the co-pilot's lights. So we'll just get that turned up, and in fact, maybe floodlight on. We don't use this light during flight as it's very distracting, but we can use it during pre-flight to be able to see everything a little bit better. So I'm just going to close a few things. Okay, here we go. So, welcome to the 737-800 cockpit. We have 6 display units, which are responsible for displaying essential information during the flight. This is our autopilot control panel. This is the map control panel, which we'll see a little bit later. This is where we see most of the systems, the overhead panel. So, the typical Boeing flow is proceeding, for pre-flight, is proceeding down each of these columns. As you can see, the overhead panel is divided into columns of sorts, little strips, if you will, and you can proceed down these, checking items that need to be checked, and then we can go ahead and do that now. So, we'll start by heading down this panel. The yellow damper will be turned up a bit later. The other Boeing philosophy is that orange lights are bad or something that need to be dealt with, but a lot of these lights will extinguish once we have actually done what we need to do. So I'm going to ignore ones that need to be ignored, and we're going to discuss what would actually need to be discussed. We're going to turn on all of the fuel pumps, and those will come in a delightful line. We'll proceed up here, switch this voltage switch to ground power, and check that everything is what the component switch is. Make sure cabin utilities and flight entertainment is on. Make sure ground power is on, that's already established. Next we'll proceed down this little thing to confirm the certain brake light on. Equipment cooling should be in the normal position, which it is. We can turn the emergency exit lights, and we'll turn the fasten seatbelt chime on. Proceeding down, we're going to turn on the window heat, as the windows need to warm up to be flexible before we start the flight, just in case they get hit by something and need to be flexible so they don't shatter. We will turn on the probe heat a little bit later, otherwise the tubes will quite literally melt. And we'll we'll go ahead and turn on both electric hydraulic pumps so we have electric hydraulic power up at the engines. Proceeding over to this panel, switch to the co-pilot for a little bit of a better view. This is our air conditioning panel, essentially. We have two air conditioning packs, or units, if you will. We're going to turn both of those on and make sure that, actually we can't turn those on by mistake. I'll turn those on a little bit later. But I do know this needs to be closed. We're going to set our pressurization panel now. Flight altitude today will be 35,000 feet. Landing altitude will be approximately 550, and we'll turn the local light on. No, we don't need to turn that on. Okay, so we'll be flying online with online ATC today, so in order for this to actually work properly, we're going to need to actually submit a flight plan to the online service, which I will now do, so please excuse myself for approximately 3 to 4 minutes. Alright, there were a few lights I forgot to turn on earlier. There are these panel lights down here for the center console, which is mainly used for communication purposes, communication of ATC, communication with other aircraft. Alright, so now that we have all this pretty much ready to go, minus navigation, we're going to give ATC a call and ask for clearance on our file to route. Looking at this information right now, I know that we should probably call tower, which is on frequency of 118.7. So, I'm just going to create a little bit of a text, and this should do it, and we'll activate VHHH.
Push back at discretion, call for taxi, Canada 660 heavy. Air Canada 174, can you repeat those blockages to you for confirmation?
Okay, so let's get a notepad document up, and we're going to get ready to copy our route clearance. So some preliminary information for the dock. We are WestJet 92 today, gate 2, IFR to Montreal.
Dock is out for 174.
Actually, on that note,
Yes, Air Canada 174, could you repeat the squawk I gave you for confirmation?
120.2.
Yes, squawk. Runway 23 and ILS runway 24 left, departure runway 23 and runway 24 right. Advise ATC that you have information Zulu. Toronto International information Zulu. Toronto International information Zulu. Weather at 2300 Zulu. Wind 290 at 15. Visibility 15. Light, no showers. 3,200. Jetted 6,000. Broken. Temperature 1. Dew point minus. Altimeter 2. Niner 7. Niner. Approach ILS runway 23 and ILS runway 24 left. Departure runway 2 and runway 24 right. Advise ATC that you have information.
Alrighty, let's give him a quick call and we'll just flight plan should have filed, so we'll just call for confirmation. Just make sure on the correct frequency we are. Double check. Toronto Tower, good evening. WestJet 892 at Gate Bravo 22, requesting iFly to Montreal.
WestJet 892, 32, Montreal. AT3, 100. Off runway 24 right. Walk 5512.
Go to Montreal via K3 departure. Departure runway 24 right, squawking 5512, WestJet 892.
WestJet 892, that is correct. Push to discussion on call for taxi.
Push to discretion, call for taxi. Okay, so now we have that information that we need. We can fill in the other information. So we're going to go down to our CDU and go for nav data out of date. Go to position initialization. So the 737-800 basically is navigated by two navigated IRS units, and these essentially tell the aircraft where it is in space, how fast it's moving, where it's going essentially. So we need to align those, which will take about 8 to 9 minutes.
Toronto Tower, Jazz 902.
You can actually check the progress up here by selecting this page, so we have at least 9 minutes.
Jazz 902, information Zulu.
So in the next
Gate
page,
52 for the IFR to New York.
select our current airport. Then we can enter the GPS position, as this is most accurate. And simply prepare to initialize it.
Departure.
Origin airport is Toronto.
Off runway 24 right. Walk 5537.
Destination will be Montreal.
The Academy, you had one off right, 553.
We'll add that, and flight number today will be WestJet.
Round 2, that is correct. Push your discussion on call for taxi.
So this is a very short route. We can easily enter it. Go to our departures
All the
page.
taxi, Jazz 902.
Select the K3 departure, then make the
Front
transition,
174.
and reselect 24 right. We're going to go back to our route, click the departures and arrivals page, go to
Runway
arrivals,
174.
enter VHABs.
Runway
We
83.
don't really know what runway we're going to be expecting in Montreal. We can
Zulu.
check the weather, yeah?
Taxi Y Alpha Mike.
The weather
Alpha,
tells us we should be
Hotel,
expecting
Hotel
a 2-4
Okay,
right
so
arrival. So we'll
23 Alpha,
take
Mike,
VHABs
Alpha,
3
Hotel,
to
okay,
24B
what's
via the make a transition. We're not going to select a runway just yet. We don't need to. We can now get a performance initialization page, enter a cost index of 25, which is essentially what determines how fast you're going to fly versus how much fuel you're going to burn. Reserve stay
Toronto Tower, Kansas 50, for taxi to T3.
grabber 0 fuel weight. And cruising altitude today will be 350 or 30,000 feet. We'll execute that as well. And when limit today, a very derated takeoff, as we don't want to stress the engines out more than we have to. 45 degree assumed temperature, it was a decent amount of thrust, and that'll give us reduced. It's fine. Flaps 1 today. This will give us
Back to the Alpha, Mike Alpha, to hold short of 23, follow traffic in front, Air Canada 660.
45 gets entered in this window, and 5000 gets entered in this window. He did not tell us to do this. This is just stuff that I know from departing out of Toronto. He should have told us, but he didn't, so I'm not going to get too concerned about that. Turn my flight directors on essentially is a limited autopilot mode that tells us where to go on this display, well, eventually at least, but does not actually navigate the aircraft. For that, we have the 2 autopilots right here. We won't be engaging them now, of course, because we're still setting up the gate. I'm going to turn our 2 VOR receivers on just to cross-check any information. Turn a flight path vector on and terrain, data, airport modes on. This map will light up as soon as these are done aligning, which is now down to 6 minutes. Okay, so let's load up the aircraft via the menu here. We're going to go to the payload section and get a full load of 174 passengers. That's a 95.4% load for this aircraft, which is perfectly acceptable. Now we just need to go back to the performance initialization page and double check the zero fuel weight. There. We have to verify the takeoff speeds, which we'll do. And of course they've now changed. Unless we could reselect flaps on that. Yeah, there we go. Takeoff speeds will be deleted. I should probably enter the information we'll be using here. Noise abatement departure procedure 1. So deceleration height 2,000 feet rather. Thrust reduction will be at 800. Runway wind is 290 at 15, which is what we already mentioned. Click there. Good. Now we'll get our fully updated V speeds, which is a revised V2 of 152. We'll brief this, of course, before we take off. I'm just rushing through it because I like doing that. Okay, position light goes to strobe and steady. We'll turn the anti-collision on light a little bit later. We can turn the wheel light on now. Whenever we're done loading the aircraft, we can close the forward entry door through this, and we can retract the jetway, so to speak. And we can see the jetway moving around and the wheels moving in the wrong way. I'm not overly concerned about that now. We were given 2979 on the altimeter. We'll just go up to our control here and set that up. So we actually have a correct altimeter reading today. That would be much appreciated. Okay, we'll eventually go through the route. Right now I'm just trying to get through this. Okay, so assuming we have approximately 5 minutes before engine start, which is correct, we can start the auxiliary power unit. This is essentially a small jet engine in the tail that provides not only power but air for the air conditioning. And should be able, you can see the wheel well lights over here, by the way. Should be able to hear it spin up pretty soon. There it goes. Okay, so as you can see, the exhaust gas temperature is going up. This will eventually stabilize. We'll be able to move power off the ground power coming from the jetway. Or actually, my mistake, coming from a ground power unit located on the ground to a fully self-sufficient aircraft-mounted unit. Now that we have the hydraulic pumps on, we can now turn on the yaw damper and it should stay activated. There we go. Only 3 minutes remaining on that. Then we'll have to do a quick check of the route and we'll be good. Everything else can pretty much just be left. So I suppose we can brief what we're going to actually do for departure. Since this is an RNAV departure, which essentially means you're navigating via a set of waypoints rather than a set of radio things on the ground, we need to arm LNAV, or lateral navigation. The two main modes of this autopilot are lateral navigation, or LNAV, and vertical navigation, or VNAV. VNAV manages the altitude and speed of the aircraft, LNAV manages the direction of the aircraft. We have various other modes as well, VOR localizer, which is for tracking radios, approach, which is for tracking an ILS, heading select, which is pretty self-explanatory, but most of the time we're going to be using LNAV. So we're going to need to arm that before we we'll arm it off the ground, pretty much. There's a function on the 737 and most other aircraft known as TOGA. Switches are right there. What this essentially does is if you have the auto throttle on, it'll give you automatic takeoff thrust, followed by, if you're going to a lower thrust setting after takeoff, it'll automatically reduce you to that. Not only will it do that, it'll give you takeoff guidance on the flight director, which I'll show you as soon as this is actually working. So it's a very useful tool. You can set thrust manually, but most pilots use this feature. And it's complaining that I'm running low on disk space, but I don't really care at this point. So this display down here is not overly useful. We can use it to describe, just to show just a few pages, hydraulics, and more useful engines. It's useful as if you can click the button twice and to get the displays right there, and then you can click the system page and it'll put those. Okay, we're getting a drag required message we'll deal about when it comes to that. Looks like the terrain map is screwed up right now, so we'll just close that. And we're showing approximately 1 minute remaining in the sequence. Okay, we're going to go and connect to the APU. We'll see APU gen off bus. We didn't see that before, but basically means that the generators are available.
Running for departing traffic.
You'll notice we couldn't turn this on before because we didn't have a source of air, but as you can see, we should be able
line
to
up
see
on 23.
this needle is slightly moving, which means we have enough pressure to turn on both air conditioning packs. We're going to set the temperature a little bit lower, actually. It's usually kept around 24 degrees Celsius, which is a bit warm for my liking. Okay, we have our route. So, looks good. Map a range of 10 miles. With that, we're going to enter our ATC assigned transponder code, which is 5512. And we'll turn the traffic display on, in these little dots. We're going to go to the plan mode now, which essentially shows us all the waypoints in a row. We're going to go to the legs page in CD, and we're going to step through the route just to verify that there is a discussed video. We'll get directions to which our top of descent is right there.
Your plan is 650 for takeoff 23. Call 2577 airborne.
Going through the route, and it's roughly in the upper right direction, which looks pretty good to me. Okay, so we'll choose a runway when we get there. I'm not sure which one we're going to pick now, but that's perfectly fine. Alrighty, so we've been informed that pushback and engine start is at our discretion, so we'll take full advantage of that. Disconnect the ground power unit, pitot covers, and the chocks. And now this aircraft is fully self-sustaining. I turn on the probe heat, and I believe that's all we need to do before we start. Now let's just take a little bit of a look at where we are. This is Terminal 3, which means the runway 24 right is approximately down there, which means we're going to need to push back essentially 30 degrees nose to the left. And then we'll make a turn onto there, or probably just proceed via his assigned directions. I presume that's what he's going to give us. We'll go back to SWAT view and cockpit. I said cockpit. Thank you. Let's just do a quick update on chat, and nobody's asking any questions. Okay. On the side, we've been broadcasting 29 minutes of my incessant talking, which is quite a record. Okay, so pushback is accessed through the same menu over here. So we'll simply pull up pushback. Switch to meters as a unit. Turn the nose to the left about 30 degrees. This is very rough. You'll have professional crews doing it. In real life, obviously, I'm not a professional crew.
Ground, cockpit. Go ahead, Captain.
Some numbers here.
We're all set to go up here. We've been cleared to push and start at your discretion.
Roger that, ready for push. Power and air clear, doors closed. We are ready for pushback. Start brake, please.
Okay, parking brake is off. Clear to push.
It appears the audio stream's current bitrate is lower than the recommended. Okay, so. No, this is perfectly acceptable. Okay, so nothing's wrong, it's just YouTube being stupid. Yeah, it's just being stupid. Not receiving enough video. But it is. Okay, so we're pushing back now. So starting with 737 raise first, we turn off the air conditioning so that we have enough pressure to start the engines. Then we'll switch to ground start, which basically means we're going to push air through the engines until they can start. Then we're going to click the fuel cutoff switch to idle, which will, at a certain speed, introduce fuel into the engine. Following that, it'll be able to run at its own power. Right now we're pushing a tremendous amount of air through it, so this is going to go up as it's working harder, and this is going to go down as it is. They're probably going to inform us. There we go. Setting the parking brake.
Alright, brakes are set and pressure's normal.
So, looking at N2, which is the statistic of the compressor inside the engine. We're waiting for that to reach 56%, it's currently at 42 or so. When that happens, this switch will automatically click to the off position. We're going to switch to continuous ignition just in case something happens during the takeoff roll, or after that we'll switch it off after because there's no point in using the igniters and the combustion is fully self-sustaining. Okay, so we're going to start up a right engine, so we're going to close this isolation valve, which essentially splits the air conditioning system into two separate areas. We're going to turn on the air from engine 2. As I said, we're going to switch this over to continuous. This should rise, and we'll select the right side pack to on. So we're still getting air conditioning when we start the second engine.
Attention all aircraft, will be closing in 1 minute.
Okay, so that's fine. So we'll turn the generator bus here to on, so we're running off that engine over in the APU, and we'll start the other engine. So cut off switch to run, which is a lot more convenient than it used to be. Back all in the day, the 80s and 70s, you actually have to manage a fuel running the engine. Now it's all automatic, so you just set the fuel to on, set the switch to on, and we're good. We'll switch this to high flow. We had the bleed air capacity to do it, and it'll help with that. We can turn runway, turn off taxi lights on to help us see. We can turn the anti-collision light on.
Tower, Jazz 902, we copy your closing. Do you want to head over to center for the taxi then?
Jazz 902, you can remain on the frequency for now unless it's going to take you longer than 15 minutes.
Jazz 902, we are ready for taxi. Request taxi via Preflight Departure.
Jazz 902, taxi to DIC facility.
Paper, I'm looking for the ice pad.
Okay, so
yeah.
now what we're going to do is turn the flight off because it's very distracting. We'll still be able to see everything in person. It's just hard to see the
Here's Jazz
numbers.
902. Taxi Alpha Bike. Victor, cross 30 right. Into the bay.
Okay,
The
so
Alpha Mike
switch to
Victor
the
crossing
on
green straight
position,
into
so
the bay,
we can
Jazz
access the
902.
traffic. I'll switch to TA only, which is perfectly fine. Toronto Tower, WestJet 892, ready for taxi. Not sure if we should remain on this frequency or switch to Toronto Center, just looking for some advice. I always sound stupid over We're ready for taxi, just wondering if we should remain on this frequency or switch to Toronto Center on 125.77.
You can stay on that frequency for now. Yeah, so runway 2 for right. Hey, this is 0. Taxi via Bravo, Delta, and hold 2 for right.
2 for right via Bravo, Delta holding short of 2 for right, WestJet 892. Alrighty, we're good. So, flight path vector is on. This is pretty much looking okay. Both engines are stable at roughly the idle position, so we're going to switch generator to on. We're going to switch the APU bleed switch off, and we'll turn the engine 1 bleed switch off. This valve will get opened, and we'll switch this on. This is the standard air conditioning status of the aircraft. Alrighty, we're ready to taxi. We have the taxi lights on. APU goes off, as we no longer need its burning useful fuel that we don't really want to see burned. We're going to verify generator 1 and generator 2 are both functioning well within parameters. And we're just going to verify that the trim setting on the takeoff page. 5.42. We'll just drag it down until it reads 5.42. There we go. Right. Except I went too far. There we go. Okay, so altitude 5,000, heading 152. We're going to switch LNAV to on. We're not going to arm the autopilot just yet. This will just give us lateral guidance. Should give us lateral guidance, but it's not. Okay, let's try this again. So flight director on, LNAV on. Okay, so it is actually arming up there, which is good. Set the map mode to a range of 5 for taxi, and we'll take Bravo Delta. Now, if I recall correctly, Bravo Delta, we're just going to really quickly pull up a taxi chart, just so I remember where exactly we're going. Starting from Terminal 3, I think that's what I think it is. That's not the taxi chart you're looking for. This is a other taxi chart, which is an actual diagram. Okay, so head out from it, head down Bravo, which is the next taxiway, not the first one. Take that all the way down to the lowermost taxiway, just take it all the way down. That's easy. So, there's the brakes, and smoothly increase thrust to about 22-25% one. And the aircraft should start rolling. We are pretty close to our maximum weight, not counting fuel, but the aircraft does have quite powerful engines for its weight, so we should easily be able to just maneuver around like so. We're most likely going to exit runway around Alpha Juliet. We're going to take a look at that sign, although it's not really overly important. We're just going to try to follow the taxi line and whichever one closest. Since he didn't give us a specific one, we're good. Make sure the transponder is actually working here, which it is. Good to know. Did that disconnect us? No. Good to know. Okay, so we're going to switch this auto brake to RTO, which is rejected takeoff. In the event of a rejected takeoff, if we need to abandon it, all we have to do is pull the throttles back to the minimum position and the auto brake will take care of it and apply maximum braking. So as we can see, this is Alpha Juliet. So we're just going to follow the line as smoothly as possible until we reach the next taxiway over and take that all the way down. There's pretty decent signage, so I'm not too worried. We're going to set our flaps position to 1. It can be seen in the dial right side of the screen. It's currently having the needle move. There's several flap positions that you can use for takeoff. I prefer 1 because it produces the least drag, so you can get the heck out of Dodge quicker, which is always a nice thing to have, honestly. And it also saves fuel, which is incredibly important if we're going to keep fossil fuels in the ground. So we're just going to go through what we're going to do on the departure. So we're going to push the toga switches at the beginning of the runway and pretty much go for it. Steer all the way down. At 145 knots, 147 knots, I believe, we're going to make a very smooth yet firm pitch up and go into the air. I'm going to pull the gear up almost immediately after. At 800 feet above ground level, the auto throttle will automatically reduce thrust to the climb setting. This is the departure procedure required to reduce noise at Pearson, especially at these hours. Following that, we're going to continue climbing until we reach 3,000 feet above the ground, at which point we're going to nose down.
Alright guys, I know you're ready to change taxi.
Okay, we're going to bring power back so we don't go above our taxi speed. I'm going to pull up this chart again, decide which way we have to. So we do have to stay on the right side. Actually, I don't think we do. No, we do.
Alright, say again, we'll need the west contact zone for 902.
I think it's this way, honestly.
Okay,
Yeah.
So we're looking at 779. This is Zulu.
Because it's always the rightmost one. So it's just confusing sign, which is I can't read my sign from this direction. Make a very smooth turns. The goal is to keep the aircraft essentially around 20 knots.
Victor Foxtrot Delta,
which is a comfortable taxiing speed and one that actually gets us where we need to go really quickly. We're just going to verify flaps are set to 1, auto brake is RTO, and it's not complaining. Good to know. I don't see anything out of the ordinary, and this aircraft is advanced enough that it would alert us if something was going wrong, so I'm not overly concerned about anything. Okay, just to be clear, what is this? This is T. I think I might have accidentally turned onto the wrong taxiway. No, we're still on Bravo. I'm not seeing T, there's T. Okay, so we're pretty close to where we need to make our left turn to get to the planets of the runway. As you can see on the map, we're still a fair distance away, but we're motoring down this, so we're good. Let's just take another look at takeoff speeds 148. Sorry, my mistake. I should probably explain the importance of V2. Okay, so V2 it's basically related to when you can get the aircraft off the ground into a climbing state. So if one engine fails on takeoff, then we're instructed to climb out, essentially gain altitude on the single remaining engine at V2, which is 152 knots. If there's both engines operating to get a more efficient climb, we're going to climb at V2 plus 15, which is automatically set by the autopilot. Now this is our turn. We're just going to make a Need for Speed style and just make a very, very nice sweeping left turn. Yeah, he did tell us to take Delta, not Charlie, which are just, if anybody's getting confused, it's just this is Victor. No, I'm doing this wrong. Okay, so, let's try to find a taxi sign. Okay, so this is, that's Delta. So I actually did make the wrong turn. We need to actually get the hell out of here. Good to know. Good to know. Okay, so, bring your throttles down to a little bit more of a reasonable state. We'll make a left turn here. If he complains, we'll say it's the scenery.
Driver 2, I think, is Bravo, turning left on both. He leaves the traffic and then follow straight ahead.
Follow the
Let's
west
verify
cat
we're
head,
actually-
or right,
We are indeed on Delta. Good to know. So we just continue down here. Bring the power back up a bit. That's way too much actually. We'll bring it down. So, with regards to the autopilot, I'm going to engage flight level change, which is essentially you put in as much power as you want, and the aircraft will pitch up or down to maintain that speed in a climb or descent. So if you have more power, it'll maintain the speed and it'll obviously climb faster, and vice versa. Try and take us to the end of our runway. We're not overly far out. I could probably fill up these displays, but I like doing that. So we're gonna right to the end of a runway. We could definitely take off with less than 3,000 meter runway, but it's not really an accepted thing, so no point in doing it anyways. We don't need it. It's not too long of a taxi. We're gonna get the next frequency, which is 125.77, which is the next ATC we'll be talking to. All the photos can go to the arm position, just in preparation for the impending toga. Okay. I think we're coming up to our end to turn. Oh, no, okay, there we go. So we're just going to click this. This will tell us if anything's up, and if it was, then it would light up. It's not lighting up, so we're good. So he'll probably ask us to call him. Our current instruction is to hold short of the runway. To take a look at our taxi chart, which is unfortunately off screen. That's after we make the turn, not before. So we could actually take a look at the other aircraft here. Our traffic. I don't actually remember which one it was. There's a whole bunch of traffic in the area. But we can... This guy's still online, right? Yeah, okay. So we'll just make sure we're still on the correct frequency. We'll make the turn here instead, rather than going to the very end. Apparently there's an FMC push to reset. Okay. So our FMC is giving us a message, which I'm personally fine with. So red lights, Toronto, and a lot of other airports around the world signify stop here unless you have clearance to cross. We don't have clearance to cross, so we're going to stop.
892, and on 125.77 airborne. Wind speed 015, let's take off right.
Clear for takeoff 24 right, we'll contact 25.771 airborne, WestJet flight 892. And I screwed that one up, of course. I think he said clear for takeoff. Yeah, he said clear for takeoff. He didn't complain, so we're going to assume that that's what he said. Okay, just calculating. Once we're done, flaps 1, auto brake RTO, auto throttles armed, LNAV is armed, run armed unit. Okay, this is runway 24 right as Evans moving. We have clearance now so we can cross the red lights. We're going to do a rolling takeoff, which basically means we're not going to stop at all. We're just going to make the turn. Okay, so in order to actually take off, first we need to make sure the engines are stable at a higher power setting than we were using during taxi. We'll so move them up to 40% and want to engage. They are stable, so we're going to click this button here, which is actually in the throttle quadrant. There's a shortcut there. The autothrottles will move power up.
95, 1 for route, 2 for route, we're departing traffic.
Right, just,
We're going to steer ourselves down the center line as best we can. Probably could have pulled up VHTS, we're not going to do that. Okay, so now you can see the pink lines on the blue and brown thing, which are the flight directors, so that's going to tell us where we go. So,
V1. Rotate.
so we're going to slowly but surely make our way up to about 15 degrees of nose up pitch. Hold the plane wings level, pull the gear up, there we go. So, the white number that is moving up in tens is the, that we're going to switch radios over because we can. We're going to maintain approximately 167 knots in this initial climb out. 800 feet, there's the climb too. And we're going to keep going up at this speed. We'll give ATC a call.
Air Canada 660 heavy zone space, Cleveland is not online since we've seen a comment and look for Chicago in a bit. Have a good flight.
650, thank you very much, have a good night.
Turn center, WestJet 892 airborne, 2400 for 5000.
WestJet 892, Toronto, good day, calling level 230.
Up to 230, WestJet 892. Okay, so they cleared us up to 23,000 feet, flight level 230, we're doing right now. And we'll click the altitude intervene button as soon as we get a chance, which should be right now. Here we go. So we are almost, okay, we're turning, we don't want to do that. Just gonna pitch over here. And we're gonna maintain this track. Okay, now we're there, so we can pitch down. We're gonna click the VNAV button, we're gonna click the autopilot button so I don't have to fly anymore, because I'm sort of tired at this point. We're gonna accelerate to 230 knots at this point, which is the maximum speed permitted by these flaps. You can set the auto brake off since we're not going to be using it for obvious reasons. This goes off instantly for it to turn on the landing lights, but I don't think anybody will really notice. So the continuous ignition is off. Air conditioning is going very well.
WestJet 892, turn left to right, keep around course.
Okay, I'll get it in just 1 minute. Left direct to save around course, WestJet 892. We'll click that in. I don't know why I use the pop-up one. It's going to automatically command a left turn. Now we're, if you can see, we're on up green number. This basically means we can retract the flaps and go all the way up at this point, which we'll do. This will let us accelerate to our maximum speed of 250 knots below 10,000 feet, and we'll climb up at that speed over cruise compliance and crest setting. This will gradually increase over time until we reach maximum power, maximum allowable power, at least in the climb.
Toronto Center, got 452 will be 10 Alpha Winter, flight level 330.
Okay, so we still got a decent amount of fuel
Toronto
remaining.
Center, good evening, Jazz,
And over and out, an
904.
estimated of 1.9 tons remaining. Yeah, although I think that'll...
Jazz 902, Toronto, good day, identified, clear direct nav and on course, climb 11, 11,000. 11,000, having Jazz, 902.
You might see it come off at more this altitude. Your shell looks good to me. If you'll notice, the pressure was previously low in the gauge before it's come up.
Delta 432, I think you were calling, but you're not actually going to be entering my airspace. You can contact these on 130.
Expand the map to about 40 miles out. And the white circle is the traffic avoidance system, for anybody who's curious. So the white line is that is merely the predicted path of the aircraft, and we're going to go turbulence. Lovely. We'll grab a few shots from inside. Absolutely beautiful aircraft. I love this aircraft. I prefer the earlier 737s, to be honest, but this is a really nice aircraft in so many ways.
To center, Delta 4, CYYZ-VHHH 15 southeast and 1 flight level 332.
Hey, Delta 432, you're not in my airspace. Contact Cleveland Center on 134.9.
Please tell me I'm wrong.
34.9, 432.
Yes, okay. That's okay. So I think we'll just go through a few of the features of, I guess, here's 10,000 feet, we'll do it after. We're going to accelerate up as there's no longer a speed restriction to 298 knots, which is what the flight management computer has assigned as the optimal speed to climb up to approximately 35,000.
So on the center, we live in 1116.
Oh, I guess we can go through a little bit of an
50 miles
explanation
to
of features of this aircraft.
Romeo Ninja Bravo
So
1
this
to
is
flight level
the legs
392.
page. This is the list of all the waypoints we're going to be navigating to,
Console
all the distances
1116
between
Toronto,
the
good
predicted
evening, squawk
altitudes
code
each.
5523 and
RMP/actual. RMP is how accurate we have to be. So one RMP is that the aircraft has to be within 1 mile,
Flight level
a circle of a radius of 1 mile within the
Westjet
altitude.
892, climb for the 350.
Up to flight level 350, Westjet 892. Okay, so we'll do that, and I'll continue explaining. So, have a bit more on this knob, and we'll do that. Interestingly enough, we still only have one viewer on it. Okay, so, actual is, the plane is on the 95% sure that it is within a circle of 0.06 miles. So we can actually check this on one of these pages. I believe it might be the first page. Nav status.
Console 1116, you are radar identifying the flight level 390, continue its path.
Okay, so as we can see here, so basically the plane is, okay, can you stop? We're gonna fix that now. So basically it's complaining it can't make this. It just can't do it. So, what we're gonna do is enter a restriction here, 220 knots, so the plane can slow down ahead of time. Okay, so I think this is the best time to, since we're not really doing anything, we can pull up a chart of where we need to go from Montreal, so we can actually select a runway, because there's 2 parallel runways that we can choose from. They're on different sides of the airport, and I think we must find out which one we're going to use. Okay, so we're taking the Habs through arrival today, and we'll take a taxi chart. Okay, so, this is off screen, of course, we're just going to rotate this up. So, the 24 right, actually that's an almost completely useless chart. We're going to pull up the other chart of the airport. That is just as useless, actually.
Yeah, with Delta 470, Toronto.
Actually, this is fine. Okay, so, we are coming at gate 4. Well,
With Delta 470, you filed the Amoeba 2 arrival, but you're a little bit north of the track there. Are you joining the star?
4. So I'm gonna say east side of the main terminal. Okay. Main terminal. I'm still struggling to find this on the chart, stupidly enough. Main terminal. Main terminal. Main terminal. I'm very confused now. Okay, so where is this actual... Oh, I think I see it. So if we cross-reference that with that, there should be 2 fit. Okay, so we are... So we'll take 24 left in that case, because that's the correct side of it. You can just come off right at the end and roll off onto our gate. So, ILS to 24 left. We have secure arrival. Make a transition. No glide slope. No transition. We would like a glide slope. Execute that, and it'll pull up. Pull this up, put that to make this route one route, not multiple routes. Set is 220. We will set this here. So that we have to make 220 knots over 240 knots. That will allow the aircraft to be slowed down ahead of time. This is not good. I drop quantities down in one of the systems. Make it a fun. So, this yellow box, I guess I better explain it to anybody that's unfamiliar with this.
And the 470, are you going to be joining the star, or would you need sectors?
Essentially, we use a pressure system above
We
what we
would
call
expect
transition
vector
altitude
speed with times of
of,
470.
this is a standard aircraft rule of 29.92 inches per
Okay,
year.
descent to 470, turn left heading
This is to maintain
190
spacing
degrees.
At higher
Left
altitudes,
left
just
heading
regardless of
190
the local
times
altimeter settings, we would have to
470.
keep changing it, because it doesn't really matter if you're 1,000 feet or 500 feet above the ground if you're at 35,000 feet. So what we do is we click the standard button here, and this sends it to the standard barometric pressure. Now the transition altitude, which is 18,000 feet in Canada, is where you make the switch over. So when we cross over at that point, when we're sending it to Montreal, we'll grab the local pressure and fed it into our altimeter so we get the right altitude information. We're going to continue going up. As you can see, this climb 2 has changed to climb, which is what I was talking about, thrust being restored. Engine parameters are all at the normal levels. We can even take a closer look if we wanted to. Down here with the gauges.
Descent to 470, heavy descent 8,000 feet, turn altimeter 29er, set minor.
Information. Did we turn the seatbelt sign on? I'm pretty sure we did.
With times of 470, can I
Does this even have a seatbelt sign? I'm pretty sure it does.
Descent to 470, descend 8,000 feet, turn altimeter 29er, set.
Seatbelt sign. Oh, this is a conundrum for sure.
8,000 feet and 290,
So
the
not
7.
down here.
With times of 470.
So 47. Where are those run off to? Are those river speeds? The switches. Okay, I guess it doesn't really. I'm probably missing something on this. So, very relaxing. The speed doesn't really climb overly fast, particularly compared to its predecessor, ironically enough, but we'll eventually get up here. So, Lou is in the process of displaying this. Not really. Well, I guess we could talk about the features of this aircraft, various safety features and so on. We can click the menu button, and that takes us to this list. We can select ACARS, which is basically
Jazz 902, contact Cleveland Center, 134.9er.
to be perfectly honest. These are just things from aircraft to set them up. You can load stuff out as well as over there at that entity. And this is a variety of options about the aircraft, so we can select the equipment we want, the autopilot panel, acceleration height, so that we're just, these are the WestJet configuration options that I've set. So we're going to go into the FMC portion of it and pull up the other. This is the index is what I really wanted. IDEP page. This basically tells you what aircraft are you flying, because of course, if you're flying in a mixed fleet, and WestJet operates pretty much every model of 737, you can have various models and you're not quite sure which one you're flying. So this tells you flying 737-800 with winglets, engine rating 26,000 pounds of thrust. We're using nav data 1511, which is active until November 11th for Members Day. I haven't really updated it yet. This is the performance page. I sort of glossed through this a little bit earlier. Wouldn't worry about that. So GW/CRZ-CG, or cruise center of gravity. This is the gross weight of the aircraft, which is everything loaded on it plus fuel. Centers of gravity is what percentage of it, how far it's back, essentially. Planned fuel is not something I use. Fuel on this side is just how much fuel you have remaining, which can also be verified with fuel gauges right here. Almost slightly off here. Reserves 1 point. This is basically the amount of fuel that you want to save at the end of the flight. Cost index, as I've explained, is a very complicated equation. It's pretty much a lower cost index will result in lower fuel costs, as you'll burn less fuel by going slower, and will also result in more time costs. The aircraft won't get there as quickly. So it's at a higher rate.
121 Toronto Canadian clear to Calgary
Zero
via
fuel
the
weight
M6
is
departure,
everything
live
on
mode
the aircraft
transition
minus
flight plan
fuel,
routes.
which is useful for
Departing runway
fuel loss.
23 and squawk code
Tripping cruise
5562.
altitude trip is what it would see as the most efficient altitude for our current weight. And trip cruise altitude is what we're actually doing. In BUs is to go really high, and this is it's a really short flight, so we're not going to bother.
Air Canada 121, all correct. Push and start at your discretion. Call
We
me
could
ready
do
for
an
taxi.
offset, which is basically just flying left or right of the route. We don't really need to know. So we're going to go back to NetRef. This is our approach reference page. So this is our current gross weight. This is what all our speeds are going to be calculated based on. So it's giving us information about the runway. It's 2,900 meters long, and the information for the instrument landing system, or ILS, is a frequency of 110.5 megahertz and a force of 237 magnetic bearing. Selected a glide slope which will provide vertical guidance as we go. This is for us to select a speed based on a flap setting. We're not going to select this just yet because it's not going to be accurate, as this is based on cruise weight. We're going to burn off fuel later in the flight. And now the status. So as I was saying about this, that's not what I want to do. The aircraft is constantly shifting its position based on a variety of different sources to give you the most accurate position. So we have two IRS systems. These are basically a set of gyroscopes that just sort of rotate. And these are very accurate. These were used back in the 60s to cross oceans, as long as we didn't have anything that could really do it.
American 629 descend
So
8,000.
they had to make do with an onboard navigation unit. These are pretty accurate. So what's basically saying is
under 8,000, American 629.
the IRS it's drifted a bit, so it's not entirely accurate. So this number is going to be higher than the other ones, but that's okay because we have other methods of determining our... Okay, that's not what I want to do. Other methods of determining our position that rely on
Lufthansa 470, turn right heading 210
external
degrees,
nav
radio speed 250 knots or less.
So first of all, we have this all go in basically chronological order of when these things were actually invented. Radio position, which is we can, if we go back a page, we can see it. We should be able to. This is not okay. We'll go back to the nav status page. So we have two DMEs, or distant measuring equipment. These basically connect to ground-based navigational beacons. Determine the distance. So we're currently CYYZ and VIE, and we're getting the distance from those. And using triangulation, you can pretty accurately calculate that. If we go back to our position shift page, which gives us this, we'll see that radio navigation is much more accurate than the IRS alone. So back in the 80s, when we wanted to fly more complex routes, and you obviously can't do everything with just radio, they devised a system known as DME IRU, which is IRS units, or an IR, inertial reference unit IRU, coupled with automatic, essentially, position updates from ground-based radio transmitters, and this is actually very accurate. They used that for a while. It's pretty accurate, actually. The real game changer was GPS, which was in the 90s, and this basically is constantly feeding a very accurate GPS position into the plane. And as you can see, this one is not off at all. This one is off by 0. Well, not really off, but... So our F and C, both of them, we have two of them. This is constantly calculating the position using a certain algorithm.
American 629 descend 5,000.
Roger, down to 5,000, American 629.
Sorry about the interruption, I'm back. Some stuff I had to do. So anyways, the FMC is constantly calculating position from all of these. Uses a certain algorithm to determine which one is weighted more, and it results in an extremely accurate actual position. So we can fly. We have different standards of RNP, or recorded navigation performance. Essentially what your plane has to meet in order to fly certain routes. And this 737 meets pretty much, to my knowledge, every single RNP standard. So this thing is actually fully tuned. We can fly anywhere in the world without any issues. At least when it comes to individual routes. So if we wanted to, we could begin at rev page. However, not that the other one. My mistakes, right? This position page. I believe it's this one. No, it's inhibit, which is here. So we can inhibit a GPS update, for instance. So now we go back to the position shift page. This is gotten quite a bit less accurate. It's still within the specification required, but it's not going to be as accurate because you don't have the GPS position pumping. I don't know why those aren't lighting up. But we could leave it like this. This is what they used to do. It's not quite as accurate, but...
American 629, turn left heading 340, descend 3000.
So the top of descent is roughly Nicola.
Turn left heading 340 down the street.
There's also our transition. If we're still in this airspace, by then we'll just ask for a descent. If not, then we'll just send around for one. Everything seems perfectly fine. Cruising at roughly Mach 0.78. Almost there. But not quite. So this is actually going down as it gets more radio updates. Generally it'll stay around this point for accurate IRSs on short routes like this, but this could go a lot higher, and as you can see, it's actually, as it's updating, it's getting a bit lower, and it'll go back up. It'll stay around here. It's not going to be as accurate as a GPS, but still, for most purposes, this is accurate, which is why you can still fly those early 80s aircraft like the 757 and the 767 that were built back then without GPS, because this is still accurate enough for most routes around here. But if we want the most accurate stuff, then GPS is essentially what you want. And that's why GPS is, in the algorithm I was talking about, it's weighted very, very heavily. But it does actually, it's pretty interesting to me, seeing how, even back when they had nothing, so to speak, no GPS, scientific calculators were huge. They were sort of like having an Alienware laptop in your house. 1978.
American 629, turn left
They
in
had the first
270 degrees, showing the local lines are cleared ILS
performance data
163.
computer, which did basically what we're seeing here, when it'll calculate the speeds for us and give us.
Right, left 270, clear to local
Then they had the
629.
FMC component a bit later. In 1982, when the 767 and 757 were first released, and this had the full navigational database, so we can enter routes like we did here. And this aircraft was released in around 1997, but that was the original release of this was back in around 1982. Okay, we're gonna. How far away is that? 7 miles. Trender Center, we're showing a WestJet 892, we're showing a top of descent in a few miles, requesting descent clearance into Montreal. It's probably going to transfer us onward.
WestJet 892 is specified by airspace, so you can do that at your discretion, and switch to Unicom. Good flight.
Switching to Unicom will descend to discretion. Thanks for service, have a good night. WestJet 892. Okay, so, we'll just switch to Unicom 122S18. I'll explain it a bit later. For now, we're just going to get the hell out of here. Okay, MCP altitude. So, basically, the Unicom navigation will manage this as long as we set the lowest altitude we need, which is 3,000 feet. After that, we'll be navigating a feet now, so that's fine. We'll reset the MCP altitude, and as soon as we hit that top of descent point, throttles will come back as they are, and the aircraft will begin descent automatically. This little thingy here shows us essentially the deviation from what VFMC has calculated as a vertical path. So VFMS will try to fly this path, but if it deviates, it will let you know. And I'm not overly worried, actually. I can actually go down to between, just to make sure. We're just going to pitch down, and eventually, one of the main characteristics of this aircraft is that it descends incredibly slowly. It's a very slippery design, very aerodynamic. Which is good in some ways, and bad when you're trying to actually plan descents, which is why oftentimes you'll see 737 pilots using a lot of speed brakes when you wouldn't see them use another competitor's aircraft. This has been a characteristic of this aircraft since its first version in 1967, and it's been retained. It's a great aircraft. It has a few flaws, obviously, but learn to live with them. They're not too bad. So this number is decreasing, so we're getting closer to vertical path. If we need to, we'll drop some speed brakes. I don't think we'll need to, though. Okay, so let's just explain what we're actually going to do in this progressive vertical component of it, because we'll just see the horizontal here. So these small white numbers are essentially what this is calculating as essentially an open mode, if you will, where this is controlling everything. Now, the route we've picked into Montreal has a certain restriction here. You have to be below 9,000 feet at this point. This one, Titus, so just to clarify, numbers on the right, large numbers on the left are speeds, large numbers on the right are altitudes. The B here signifies you have to be below the altitude. Sometimes you'll see just a straight 9,000 feet, which won't have a letter. A signifies an above. Of course, we're going to contradict ourselves right here, because this should normally say 2300A, 4000B, but this basically means you have to be between these two altitudes. Whichever altitude you're at between it doesn't really matter, but you have to be above and below. And you have to be at a speed of 220 knots, which we're already going to be at because I set a restriction. So this is going to take us down part of the structure and need to drop some speed brakes. I'll just drag the lever over to about here, 50%. This will tell us the descent path is unachievable. I disagree. So there's no ATC coming into Montreal, which is why we're on Unicom. It's essentially a service that allows you to give people updates of what you're doing if you're not in controlled airspace. There's nobody remotely close to Montreal on west, and so we don't really need to worry about that at all. We can just do whatever the hell we want. So now it's time to start getting ready. We're going to choose a flaps 30 landing today, so we enter 30, slash the number it wants us to put in, which is 147. VRF is essentially an approach speed, if you will. The speed itself is the optimal speed to touch down at rather, and for most of your approach you're going to be flying VRF +5, which is 152 knots, mostly because this is a more efficient speed to be flying at, whereas VRF is a more efficient speed to be touching down at. We'll be dropping to flaps 5 partially through, and then we'll be dropping to our full flap setting of 30. The reason for this is that not only can we not fly at a higher speed with higher flaps, it'll use more fuel as we're pushing the engines harder to overcome the drag to achieve the same speed, which is why we did only a flaps 1 takeoff and we could have done higher. Because there's no point in taking all that that drag up. It just, you can't climb out as quickly. So I'm just going to be right back. Apologies. Okay, I'm back. I'm sorry about that as well. Actually, this is showing us some more speed breaks out, so going into a full flight descent. The reason we're getting this issue is because we have such a strong tailwind. It's increasing our speed, but not increasing the rate at which we can descend. That little yellow box I was talking about earlier, we have to actually play current altimeter setting, which is 2.71. Click the STD button to give ourselves an STD and bring this down by a few notches. Bing. Oh, it flops out all the way. There we go. So there's some frightful terrain away from us, but then we need to bring on 1 degrees for engine half is the order. We need to make approximately a 180-degree turn at some point. But that's not going to happen for a while. But focus on actually getting down to altitude constraints. Okay, so programming our VRAF. 737 aircraft has 2 sets of landing lights, fixed landing lights in the wingers. Header emitter limiting aside, we can turn those on now. It also has retractable landing lights, which can only be extended below 200 knots airspeed because we want to avoid excessive drag and stress on the parents. So we're going to put those on pretty much when we're descending to meet the runway. We have full speed brakes out, but for some reason these winds are vicious, I guess. We are getting better though, so pretty safe. That throttle is down pretty much as low as it'll go. We can get so we're keeping the wing light on as well, just to aid visibility at night. Make sure everything's set with a quick boot. Still nothing an issue. Excuse me. We're just gonna keep proceeding down and slowing down as well. Maybe that'll take us down to about the tightest point, and then we'll switch over to manual altitude. But I just prefer the extra control. So nobody's asking even the slightest question in the chat, so I'm gonna assume everyone's okay. Oh, I think it might just be me watching. I'm gonna assume that more people are watching just in case. We're still 1,500 feet above the glide slope. I'm not sure if we're gonna make that altitude constraint. Oh my lord. Wait. the... What in the hell was that? What is this guy? That guy was, yeah. I think I'm gonna report him to a supervisor, actually. Look up how to do that. Steep descent. I'm fine with a steep descent, personally. What's wrong with that? Okay, what I think we're going to do is drop gear. But we're going to use the speed intervene feature to keep us at a high rate of speed. So all this will do is to create more drag. Auto brake setting today will be auto brakes 1 actually, because we're left right again, room. Probably no reverse thrust either. I'm not worried about that at all. There we go. I'm just gonna wait for okay, so only 400 or so feet away from that, so we'll drop put the speed brakes up. We're gonna arm them so that they'll deploy on map when we put them on the ground. Auto brakes go to 1. Basically, as soon as we cross Titus, we're going to just turn onto, as you can see, there's 2 lines. This is the one we're doing. Remember, it's a discontinuity, so you can turn onto this however you want. Probably ATC will probably tell you how to do that. But fortunately, we're not with ATC. We can do what we want, which will likely be a direct right turn. We're gonna switch map to range of 10. Let's get to 3,000. Actually, we can monitor it. Okay, so ILS 24 left 110.5. And we'll put it in over here as well. Pull up the approach mode. We should just course as well. 237. Okay, so we are. This shows us that we are currently to the right, our right, of the actual point. Easily gonna make back in the stream, which is good to know. Switch of course over here as well. Okay, we're gonna switch over to a heading selector, and we're going to select just 90-degree rough and degree turn. We're going to set it to 200 knots, and we're going to put 2 flaps now. We're going to go 5 flaps. This is the standard approach flaps configuration. Next, we're going to arm the approach mode. Just gonna reset course for some reason. Good to know. Okay, so the 2.5 miles we're gonna continue going. Not that button, yep, but take this over to about 210. So, what we've basically done is armed mode. You can take it like here. This is, the big one is deviation from the horizontal path. This is deviation from vertical path. Pretty much making it very well to the vertical path. Thrust is going to go up because we're generating more drag. And this will automatically switch over to a localizer mode. Since it picks it up. Select all the change and just sort of travels from a wrong area, of course. For some reason it's going all the way down. I don't want to do yeah, it's rather odd. Okay, so as soon as we intercept everything, altitude equals all the way down to 20,000. We'll put that change again. There we go, there's a localizer. We'll go up to 220. Okay, it's going to give us a single channel approach, is not what we want. Double channel. That'll eventually engage once it finishes the short cell test sequence. We're going to try to get them with quad samples, which is what we're doing. So, set it to 170 knots, go to flaps 15. The ominous red bars should come down, but half an hour into the thing. I think you're into it. Yeah, there's a runway. Set onto our full VRAF speed, 152. And as soon as we can, we're going to put down additional flaps, which will be 175 knots. Oh lord, fucking Montreal Center. Okay, 128.77. Montreal Center, good evening. WestJet 892 on final approach runway 24 left at Montreal. Okay, so now you just go. Fun.
We should be going to Montreal, confirming final for runway 24.
Say again, WestJet 892. What did he say? Did he say go around?
He's going to do your final for Montreal.
Affirmative, requesting landing clearance. This guy,
Would you like to full right?
Negative, on final 24 left. This is,
Roger, with, 2 for the 16 length of course.
Cleveland 2 for left, WestJet 892, thank you very much. Okay, so now we're going to decrease that power. Just going to maintain 147, we're going to go down. We're going to let the plane land itself today, because I'm really tired. And we're going to basically roll to the end of the runway. We're slightly off, I'm not really too concerned. We're 100 feet above the ground now.
100.
Speed brakes are around and the flaps are down. We're building.
50.
I forgot to turn on the landing lights, of course. We'll do it now.
10.
And relatively smooth landing. Bring your throttles back all the way up.
Bonsoir,
I'm not quite sure what this guy's talking about, but he has a shitload of aircraft to deal with. Okay, so we're sort of slowly decelerating. Did I say 2-4 left? Did I mean 2-4 right? No, this is... Oh, don't tell me. No, this is indeed 2-4 left. Okay, so we're gonna just quickly switch to braking, turn auto brakes off, and we'll just do a quick throttle up. That'll stow the speed brakes. Okay, now I'm gonna just get the flaps up as soon as possible because the gate is right there. Looking for gate 4 tonight. So that was a pretty nice, was indeed a pretty nice landing. Okay, these can come up. Taxi lights can come on. Let's start the EPU now. So we have the source of power moved to the gate. We're just gonna pull off here and showing low fuel, but I'm not really too worried about that. We're gonna engage particle brake. Just wait for him to actually. I guess we could use this opportunity to wait for the EPU to start up. This is almost completely unintelligible. Montreal Center, WestJet 892, clear of runway 24 left, requesting taxi to gate number 4. Let's see, from Montreal, let's just go straight ahead. Runway jet.
To the gate of your choice,
Forward apron, gate of choice at WestJet 892, thanks for the service and have a good night. Sweet. Okay, so now we go into the aircraft. We have the fun task of shutting it down. We'll increase the throttle very slow. We're actually going to do a single engine taxi today, so we'll shut down engine number 1. And we'll shut down the EPU, I believe, as well. We're going to turn the EPU. The autopilot was still on. How did we go? Okay. So, EPU is taking over generator responsibilities and bleed air responsibilities.
Montreal Center, American 101 heavy checking in, flight level 3.
Now we have the fun task of finding gate number 4. Referring to our parking chart, which we hopefully will be able to find today. Please be here. Ah, shit. Okay. We need to refind it. Which is not a shit. Parking areas. Single engine taxis will save fuel on.
American 101 heavy.
Okay, so 4 is on sort of the south side of the trail. Okay, there's an electric problem I'm very aware of that. Thank you.
Roger, copy. Radio contact.
That'll be
Maintain
fine.
flight level 360, American 101.
Okay, so that'll obviously go off. Need to bring power up a bit. And of course we need to compensate with a little bit of steering for compensate for the differential thrust. Now we can go to the top view, you can see that this is sort of the south side of the terminal and our gate is going to be right there. So we'll just sort of follow the lines and hope for the best. Also want to check both the scenery for this airport and Toronto are from the same developer. I'm a big fan of them actually. Okay, so we can pretty much just use this throttle control. Looking for gate number 4. We're just going to shut down the left engines because we can, the EPU is on the left side, so we can use both the bleed air from that and engine number 2 to use to sort of control 2 separate paths. I think it's odd numbered gates are on the other side and even numbered gates are on this side, just looking at this chart. All right turns to not something smart idea to shut down the right engine. That's gate number 10. Okay, so I think that's 4 over there. Yeah, that's 4. Alrighty, that'll be a pretty short shutdown sequence. We're just gonna clear this morning because I don't really care what it is, to be perfectly frank. So we'll eventually make it over at a snail's pace. At this point. View from the wing. A beautiful view from the wing. Or not so beautiful, depending on whether or not you're absolutely petrified of flying. Okay, so we can make a little bit of an early turn here. Or a slightly less early turn if I can't find the line. Bingo. So there's the green. We'll look for the number and then you turn onto the line. It's easier for parking a car at least. Bring the throttles down. We'll just sort of coast it and really turn around. I'm not going to give a crap about those lines. We don't really have a marshaller, so we're just going to use, assuming it works, the integrated. This guy is just here.
So if we
just keep increasing power. Okay, let's see if this guidance thing will work. Otherwise, I doubt it will. Either way, we don't really need it. We can hook up to the gate just fine. It's not going to give us any guidance, of course. Oh, we just brake. Set parking brake to on. We're going to turn the transponder off. APU takes over all buses, including Mr. Bus Driver. Okay, that happens, and then we shut down engine number 2 as well. Excellent job, okay. We're going to do the reverse order that we did prior. Ignition can go off. These lights can go off, which is good. We'll leave the logo on for now. Position lights, if we have an engine running, can go on. Position light can also go on. That should not be on. And then off. Wheel light can go on there. Not that light, the other light. That. Okay. Maybe bleed goes off as we both hot, so we can leave restart commands on for now. We're going to go off momentarily when we off power. Window heat goes off.
American 421 radio set.
The electric ones go off. We don't typically tend to turn the engine ones off because we want to preserve the solenoid like on the switch. And there's no point anyways because they shut off automatically. Next thing we want to do is shut off the emergency exit lights, or when the power is turned off, they will drain their batteries. We don't want that. The damper can come off, fuel pumps can come off, the EP will keep running because it has a bit of a vacuum system where it'll draw fuel, but it's better to give it fuel on these jetways that seem to want to work today. Maybe just screaming hurry towards 737. So we can leave the lights on, that transponder goes off. This is all off, we'll turn the flight directors off. The IRU's off. Everything here looks fine, so essentially we're just going to turn the APU off, and then before we end this, battery goes off as well. And there's some random background noise. Well, that was a pretty entertaining flight, I'd say. Pretty short, but I like the shorter flights, so I hope people actually remotely found this interesting, and I might actually do it again in the future if people enjoyed it.